All right, we should be live on our Facebook page. We'll start our star party in about 2 minutes. See quite a few people joining in. That's good. We'll start the star party and the discussion in about 1 minute. All right, welcome to the first ever Tucson Amateur Astronomy Association virtual star party. I would like to offer a special welcome to our Davis-Monthan Air Force Base Intergalactic Quarantine Quest participants and everyone watching on Facebook. I'm Jim Knoll, the TAAA Star Party Manager. On the camera is my wife Susan, and at the telescope is Bernie Stinger. We're actually observing from Bernie's house in Tucson, Arizona. So TAAA has about 400 members in the club. We do over 200 star parties a year. We do it for schools, for the public, for youth groups, for nonprofits, and some of the local resorts here in Tucson in southern Arizona. So if you are interested in astronomy, especially if you live in the local area, you might want to consider joining TAAA. Enjoy our dark sites. We have 2 of them. Learn more about astronomy through either some of the meetings or some of the special interest groups that we have going on. All of our public events are listed on our TAAA website, which is TucsonAstronomy.org. We also have Facebook events listed, so anytime, once we get back into doing the live local area star parties, we'll have events listed there. I did put, we do have another virtual event scheduled for May 12th at 8:30, so that is on there as as a Facebook event, so if you want to follow that event, you'll get any kind of weather updates and things like that. And we appreciate Davis-Monthan Air Force Base, the 355th Force Support Squadron, for actually requesting this event and kind of spurring us along to do a virtual star party. We plan to do these monthly in the near term, and at least quarterly even when we get back to doing some live star parties here, because there's a lot of people that live in light polluted areas, not necessarily in the Tucson area, that might benefit and get some enjoyment out of them. We do appreciate any feedback as we're going along. I'm going to try to monitor the comments while we're doing this. Hopefully I'll be able to do that, and we'll either talk about the event, the comment as we go through it. If you can't hang with us for the whole hour and a half, which is what we think it'll take, this should be recorded on our Facebook page under videos, so feel free to come back and look at it later. I know DM is going to have, I think, some questions for their participants to earn some prizes on. While Bernie is moving and tweaking the system, I will kind of explain what we're going to see next and then Bernie will kind of take over once he has the system lined up. We'll try to comment and answer if we can, if you guys have any questions. If you're mobile, feel free to step outside if you want to, or if you want to wait and do this another night while you're watching the recording, because a lot of these objects will be viewable just with your eyes. If you have a pair of binoculars, then that might be a great way to do it as well. I will try my best to explain in the night sky where we're looking so that you guys have an idea of where to go. The weather was good today, but we had a lot of wind, so the winds kind of kicked up the desert dust. So we'll see how that affects some of the objects. They may not be quite as clear as we would like them to be. We call that the seam, and the transparency kind of goes hand in hand. So with that in mind, I'm going to turn it over to Bernie. He will talk a little bit about what system we're using and introduce our first topic.
Hi, I'm Bernie Stinger. I'm a TAAA member as well, and I'll be running the telescope tonight, as well as the image capture software and also the control of the telescope. The telescope is about 50 feet from us out in my driveway, and we're inside the garage where we can control it and do our presentation more easily. The telescope I'm using tonight is a 8-inch Schmidt-Cassegrain telescope made by Celestron, commonly called a C8 telescope. It's mounted on a Celestron AVX computerized go-to mount. And on the back end of that telescope, where we would normally put an eyepiece if you wanted to watch visually, I have a Mellencam DS10C astronomical camera with a thermoelectric cooler on it. That cools it down and allows it to look at very dim objects successfully. The software that I'll be using for those interested is Mellencam Sky software, which does the acquisition and manipulation of the image. And to control the mount itself, I'll be using a program called the Sky X, which controls the movement of the mount and where I can tell it what object to go to. So to start out tonight, we thought we'd start with what's called an open star cluster. We're going to be looking at a number of different types of objects. We've made a little variety of the objects that we're looking at. And probably the most famous of the open star clusters is what we call M45, or the Pleiades star cluster. So with that, I'll turn it over to Jim.
All right, Susan's going to get the camera back on the monitor. All right, so our first object tonight is M45, the Pleiades. I'll talk a little bit about what the M stands for here in just a little bit. The Pleiades is also known as the Seven Sisters. In Japan, it is called Subaru, and it is what the Subaru car logo is based on, except the car logo only has 6 stars rather than 7. Pleiades is 400 light years away. It's an open cluster. It's located in the western sky right now. The brightest object you see, if you look to the west, the brightest object you're going to see is Venus. If you see, sometimes the Pleiades gets confused with the Big Dipper. So once you find Venus, if you look down and slightly to the north or to the right, it will first appear as a fuzzy spot in the sky with your naked eye. You should be able to see 6 to 7 stars. And it looks like kind of a mini Big Dipper. It's often confused as a Little Dipper. Since Pleiades is 400 light years away, you are looking back in time 400 years. That is how long the light took to travel from the cluster to your eyeballs. A light year is how far light can travel at the speed of light in 1 year, which is 186,000 miles per second, or about 6 trillion miles in 1 year. So when you do astronomy, you're time travelers. Open clusters can contain hundreds of stars, up to maybe about 1,000. The nebulosity on the screen, and there is some nebulosity in between us and the cluster, but it's hard to see on the screen, and it's actually not part of the cluster. The cluster is moving through a dusty part of the Milky Way and shows as nebulosity to us. The Pleiades is known as M45, like I said earlier. Charles Messier was a French astronomer living back in the mid-1700s to early 1800s. And he was a comet hunter in his day and kept coming across these fuzzy objects that looked like comets, but were not. So he cataloged them so he would not confuse them as comets. There are now 110 on the list and are some of the brighter and more interesting objects for us amateurs to observe. There are also great objects to observe in binoculars. The Pleiades cluster is about 100 million years old. Most open clusters are relatively young and travel around the Milky Way galaxy as a family. As time goes on, gravity slowly loses out and the cluster becomes smaller and smaller until it disappears. The glow you see kind of around the cluster right now is probably the seeing and transparency, the sky glow, but Bernie, if you want to chime in on any of that.
Yeah, it's mostly sky glow because this particular object is getting down towards the horizon this time of year, and it's more difficult to image. By the way, if it wasn't mentioned earlier, these are live images of objects as we progress through them. So as I move from image to image or object to object, you'll probably notice stars streaking through the image. That's because this camera keeps running even though the telescope is slewing from object to object. So for the next object, we're going to move over to the Orion Nebula, or the Great Nebula in Orion, typically called M42. This is one of the most famous objects in the night sky and one of the easiest to spot with binoculars or with a telescope. So I'll turn it over to Jim while I slew over to that object.
All right, and for some reason I'm not seeing the comments here, so I'm going to ask Susan to chime in. If there's any questions, she can read the question, and then I'll try to answer it as we come along. But it looks like there's quite a few people online, so that's great. Last time I looked, we had about 140. So our next object is Messier number 42, or M42, and it's called the Great Orion Nebula. So it's a bright nebula or cloud in the constellation Orion. It's visible to the naked eye as a fuzzy-looking star and is the middle object of 3 in Orion's sword. So as you're looking towards the west, Orion is to the southwest right now. Once you see the belt, which are the 3 bright stars in a straight line, look below and slightly to the left, and you will see 3 star-like objects in a row, but at an angle. The middle object is a combination of multiple stars and the nebula. It will look like it will look a little fuzzy to the eye. It's worth checking out in binoculars. Orion's nebula is a star-forming area called the stellar nursery. In the telescope, you can see 4 very young stars, and the kind of Bernie's bringing it up right now, so I'm going to pause and let him kind of tweak that a little bit. You can see some pretty good color there. You won't be able to see the trapezium because it's kind of blown out in the center right now, but you might be able to kind of scale back a little bit. But the more interesting part of the nebula is the cloud around it. So that's, but just know that that really bright part is where the trapezium is, and that's where the center of the stars that are being born are.
I can try to slow down to the trapezium. We'll see if we can pull it out.
Okay. So now you're actually starting to see the.
I can see it. Let me zoom in a little bit.
And I'll put the pointer on it so you can kind of see, but right in there is the trapezium. You're going to see
There's the 4
stars.
stars right there. That's called the trapezium.
And these are 4 very young stars. They're only a few million years old. And as you can see around them, and now that we've seen the trapezium, Bernie, if you want to go back, let's show the nebulosity.
Get there.
So in the center, so the hydrogen gas cloud is a dust cloud around it. As a comparison, I said these stars are only a few million years old. Our sun is 4.5 billion years old. So these are baby stars, but they're huge stars. They're going to burn through their hydrogen fast. So they may only live 10 to 12 million years old, where our sun is 4.5 billion years old. So they're going to live fast and die young. When visually observing through a telescope, you're actually just going to see a shade of gray because the nebula is too dim and too distant for our eye to see the color. But with the camera, you can actually see the color. All stars are born out of what's called cold hydrogen gas cloud. So when the cloud, and that's what you're seeing in the nebula around it, when the cloud is used up and all the stars are formed, the group will be then an open cluster. So our sun was born in a similar nebula, and for the first several trips around the Milky Way galaxy was probably part of an open cluster. So we would have had a lot more bright stars around us. It takes our solar system about 250 million years to make one trip around our galaxy. So we've done about 20 trips since the solar system was born, since the sun was born 4.5 billion years ago. The Orion Nebula is about 1,400 light years away, so the light you're seeing in the camera and visually is 1,400 years old. But it is the nearest star-forming region to Earth. And it is about 30 light years across. Altogether, the nebula contains probably about 1,000 to 1,500 stars in various stages of formation. Bernie, why don't you kind of point out a few things? I want to see if I can get the video up here on the screen so I can see things a little bit easier.
Okay, a couple things to note. I'm sure you can see the red. That's ionized, what's called singly ionized hydrogen. For those technically minded, it has a wavelength of about 6,500 angstrom units. If you look closely right along this dark edge, not sure if you can see it, but there's a slight bluish tint. And that is reflection from the hot blue stars that are at the core of the nebula. So we have here actually a combination of an ionization nebula, which is the red, and a reflection nebula, which is the slight bluish tint from the hot blue stars. This part of the nebula is called M42, and Jim's going to talk about what M stands for later on, I believe. And this back section here is actually called M43. So it has actually 2 M numbers, but it is all the same object in the same gas cloud.
Okay, good. We have had a couple of questions, so before we move on, one of the questions is how large is the largest star? That's a good question. It's probably, and I'm guessing here, but if you Google trapezium stars, you might get an answer. But I would guess maybe 10 to 20 to, it could be as much as 30, 30 times the size of the sun. They're big. For anything to, and so it's any star to go supernova actually has to be greater than 8 times the size of the sun. And these guys are big because they're some of the first stars that are being born in this nebula, so they have lots of gas to take advantage of.
Mm-hmm.
And if there's, for any of our astronomy TAAA guys on here, if you see a question you can answer, by all means answer it. That would be good. And I think that was it so far. So let's go to the next one.
Okay, want me to do it?
Yeah.
The next object that we're going to move to is the Crab Nebula. The Crab Nebula is in the constellation Taurus, and it's called M1.
Now, before you move, Bernie, somebody had a question. Lynn asked, are you using any filters?
No, none whatsoever.
So this is just a video camera, CMOS, isn't it?
Yes.
CMOS video camera.
It's a 10 megapixel color camera, and no, I'm not using any filtration.
Okay.
So I'm going to move to M1 while Jim is telling us about that particular object.
All right, so M1 is the Crab Nebula. The Crab Nebula is gas from a star that went supernova about 1,000 years ago in 1054. So just a little over 1,000 years ago, or not quite 1,000 years ago. And it's in the constellation Taurus the Bull. So we call this a supernova remnant because it's the remnant of a star that went supernova. The nebula is in the west right now, near the constellation Auriga, and it is about 6,500 light years away. It is not visible with the naked eye, but I'm going to tell you how to find it in case you have binoculars. It's probably getting down in the glow of Tucson a little bit. Unless you're on the west side or outside of Tucson, you might be good. But if you look towards the west, you're going to see a really bright star, not Venus, but it's a star to the upper right of Venus called Capella. And it's the brightest star in the constellation of Auriga, and it looks like a circle of stars just above Venus. After you find Capella, you go to the star opposite of Capella in the constellation. So go to the far opposite side, and that's a star called Elnath. Then you go to the next brightest star to the left or towards the south. That star is in Taurus, and it's called Zeta Tauri. The Crab Nebula is 1 degree, so it's just to the right of that star, and just slightly below the line between Zeta Tauri and Elnath. So that's how you find it. If you can get a pair of binoculars, you might be able to see it. So a supernova, like I said a little bit earlier, is when a giant star's energy is stopped because it runs out of hydrogen gas fuel. And it kind of collapses in by gravity. So a star is a very delicate balance. When it's fusing hydrogen, the energy pushes out and gravity tries to compress it. Once it stops fusing hydrogen and starts running into trouble, it starts sneezing off some of its gas, and that's what we're seeing around the star right now. But then it just collapses down very quickly. And if you ever took a basketball and held it up about head high or so and put a tennis ball right on top of it and dropped them both at the same time, when the basketball hits the ground, the tennis ball is going to really rebound up. And that's the same effect that this has when gravity crushes in and then it rebounds out and the star explodes. Sometimes it doesn't necessarily destroy the entire star. As I mentioned earlier, stars have to be larger than about 8 times our sun to go supernova. So what we are seeing in the telescope and on the screen 1,000 years later is the gas that was sneezed off from this supernova. What's left is a small neutron star. So a neutron star is just made up of a soup of neutrons. So it's just very, very dense. It's rotating at about 30 times per second, and it still has the mass of 1 to 2 of our suns. So it sneezed off a lot of its mass, but it's only about 12 miles across. So it's the size of less than a city. So it's very, very dense. When this supernova happened 1,000 years ago, it was visible during the day for several weeks, and it was recorded, and very bright in the night sky for almost 2 years. Messier first thought this was a comet, but discovered it did not move. So this caused him to start his list of objects that were not comets. And so the Crab Nebula is M1, the first on his list. So if you look, I think you can see pretty well, but Bernie, if you want to enhance that any, or do you want to explain what they're seeing?
The nebulosity from that, on a good clear night with good transparency, this has, for lack of a better word, tendrils to it. And it has more detail, but because of the dusty night or dusty days that we've had, the atmosphere is a bit foggy, so it's not quite as clear as I'd like it to be, but I think you're getting a fairly good image out on the Facebook page. Okay, I think we'll move on to the next object. The next object is going to be what we call the Eskimo Nebula. It's in the constellation of Gemini.
Okay.
Okay. I'm sorry. It's designated not with an M number, but as an NGC 2392. And Jim will explain what that's all about.
Cool. All right, I'm just kind of glancing. Looks like several of our club members are responding to questions and things like that, so that's great. I'll review these again afterwards, and if I can, I'll respond to them. So if you want to come back, in a day or two just to see if we didn't get an answer. Otherwise, I'll try to keep monitoring those as best I can. All right, so this, as Bernie mentioned, is the Eskimo Nebula. It's also called the Clown Face Nebula. It's called a planetary nebula, but it doesn't have anything to do with a planet. When early astronomers who did not have great telescopes looked at these objects, they looked blurry and round, so they gave them a planet tag. They knew they weren't a star, so they just assumed that they were a planet, I guess. In reality, it's the death of a red giant star, this particular one. The Eskimo Nebula, as Bernie said, is located in Gemini, the twins. So if you look to the west and find the two heads of the twins, Pollux and Castor, so you'll see Venus again, and then you should see two stars. I believe they're up above Venus right now, but you should see two stars kind of side by side. And the Eskimo Nebula is about 8 degrees below, and I'm going to tell you how to find the degrees here in just a minute. 8 degrees below and slightly to the left of Pollux, which is the left star of the twins. It's not naked eye visible. What we can see on the screen is the gas that was blown off of this star. The blue color is from oxygen, the green from the hydrogen gas, and it's called the Eskimo because it looks like the face of an Eskimo surrounded by a large fur ruff. The nebula is about 6,000 light years away, so that light you're seeing is 6,000 years old, and has a visual magnitude of plus 9.1. So let's first talk about how far 8 degrees is. For most adults, 10 degrees is the width of your closed fist between your thumb and your little finger held out at arm's length. So 8 degrees would be slightly less than a full fist. So if you go back to Pollux, hold your fist out there, you want to go slightly less than a full fist below and slightly to the left of Pollux, and that's where you'd find it. Binoculars probably aren't going to pull this out either. You're probably going to need a telescope. It's pretty faint.
And small.
And small, yeah. Also, NGC, which this one has, it differs a little bit from the Messier. NGC stands for New General Catalog, and is a way to catalog objects similar to the Messier numbers. And now magnitude is how we classify how bright an object is. So the smaller the number, the brighter the object. So let's use our sun as the first example. Our sun has a visual magnitude of minus 27. The full moon at night, the full moon is about minus 12.5. If you look to the west right now and look at Venus, which is normally the brightest planet visible and in the western sky right now, its magnitude is minus 4.5. The brightest star in the night sky is Sirius in Canis Major, or the Big Dog. So Sirius right now is in the southwest sky, so it's going to be pretty bright. Look to the left of Venus, and it's a magnitude of minus 1.5. Under a dark sky outside of most major cities, generally the visual magnitude of plus 6.0 is the limit of being able to see it with your naked eye. And now that doesn't hold true for everything. That's primarily stars. If you're looking at galaxies or something that's spread out, it could have a magnitude of even 5 and you may not see it with your naked eye. So anything with a higher number of 6, you're generally not going to be able to see with your naked eye. Anything lower than that, you probably could. And most things you might be able to see with a binocular, up to maybe 8 or 9, just depends on what you're looking at. All right, so I think that was everything. Bernie, do you want to kind of point out the different nebulosity there? You can kind of see 2 different cones of...
Right. Well, what we're seeing here is the central star, and then outside of the central star is 2 shells. So at least 2 shells. So we know that this planetary is a reoccurring nova. It happens over and over again, and the outer shell is an older shell that has expanded out further than some of the inner shells. And the interesting thing about this nova or planetary that I find is that the inner shell kind of has a woven, threaded appearance to it. What causes that, I'm not sure, but it has a very interesting appearance because of it. Now, this is a very small object, so you'd need a telescope with some fairly high magnification to be able to see this clearly.
All right, we did have a question. We did show Venus earlier, but Venus right now, all the inner planets go through phases, just like our moon does. So if you look at Mercury, Venus, and the moon, depending upon where they're at in relation to where we are, they may look like a phase. So right now, Venus is in the process of going between us and the sun. So it is, you remember how much it's lit right now? I think it's about 30?
Under 50%
Yeah,
now.
it's probably
I think it's about 30 to 40% phase angle.
Right. So as it moves in, so if you look at it with even binoculars, but certainly a telescope, it's going to look like a little crescent moon. And so as it goes in between us and the sun, if you were to look at, if you were to go out and look at Venus, say once a week for the next month, the same time, you're going to see it getting lower and lower in the sky until it's going to set with the sun. When it sets with the sun, it's going right in between us. And if you were to look at it with either binoculars or a telescope, it would get less and less lit until it's almost down to what we would call a very crescent Venus. When it goes in between us, it's going to be a new Venus, just like a new moon would be. And then when it comes out the other side of the sun, it'll be up in the morning and it'll start waxing. It'll get bigger and bigger, and it moves around the sun faster than us. So eventually it'll get around on the far side. It'll be a full Venus. It'll come back around again, and it'll be back in the evening sky again. So it kind of goes through phases. Mercury does the same thing. Mercury just never wanders very much further from the sun than very far at all. Nor does Venus. So that kind of explains what we're seeing there. So what's next, Bernie?
Okay, the next object that we're going to is another open star cluster. Now, the first star cluster we looked at was the Pleiades. We couldn't fit all of the Pleiades in the field of view because it's so large. This next one is also an open star cluster, but it's much further away. So we can fit it within the field of view, and you'll have a better idea what an open star cluster is. It's called M67, and it's it's in the constellation Cancer.
All right, yeah, so this is an open cluster. Again, we're still in the west. So if you were to look to the southwest, Cancer is the next constellation to the left or south of Gemini's, Pollux, and Castor. So again, you're going to find Pollux and Castor, just look to the left. But unfortunately, you generally can't see sufficient stars to make out a crab. In fact, a lot of the constellations, when we're looking in our light polluted skies, they either had, well, they certainly had much better skies back in the day. They also had some pretty vivid imaginations coming up with some of these descriptions of what we're looking at. But anyway, this is supposed to be a crab. M67 is just outside of naked eye visibility at magnitude +7, but you'd probably be able to see it with binoculars as a little fuzzy spot. It's about 2,600 light years away. The cluster is about the size of a full moon at about 30 light years across, and it has about 500 stars. The cluster itself is 4 billion years old. Generally, open clusters are fairly young, so this is an older open cluster. To find it with binoculars or a telescope, again, look toward the west. Look below and to the left of the two Gemini twins, stars Pollux and Castor, and you're going to come to a bright star called Procyon. From Procyon, you want to look to the upper left toward the south and higher in the sky, about 40 degrees. So that's about 4 fists, adult fists at arm's length. And you're going to come to a bright star called Regulus, and that's in Leo. Once you find Regulus, it'll kind of look like a backward question mark, and it's pretty high in the sky right now. So now go about half the way between Procyon and Regulus, so about halfway on the straight line, imaginary line between those two stars, and then look about 5 degrees or half a fist to the right or above that line, and that's where the open cluster is. And there it is. Nice, lots of stars. Clusters, especially if you've got some dark skies, clusters or open clusters are absolutely gorgeous in a telescope, either in a camera or visually, because you can just see so many stars. You can see a lot of, they almost look like they're taking on a three-dimensional look when you have a really dark sky. Bernie, anything else to point out there?
Oh, I know there's some background galaxies in the image, but I don't think the sky is dark enough to pull them out, so I'm not going to try pointing them out.
So hopefully you're able to kind of pick that out. That one should be visible with some binoculars. Sometimes, I didn't mention this earlier, it's helpful to have binoculars mounted on a tripod. And so you can get, like from Starzona here or Stellar Vision locally or two astronomy stores, or online, you can get adapters that would allow you to mount binoculars to a tripod. Another way is to get like an Adirondack chair or some sort of reclining chair where you can get comfortable, so you're able to sit back and hold them steady, because that's kind of the tough part with binoculars. All right, what's next?
All right, we'll move on. Okay, so the objects that we've been looking at so far this evening are all objects that are within our Milky Way galaxy. They've been in the range of, what, Jim, 1,000 to 5,000, 6,000 light years away.
Yeah.
Which is a long distance, obviously. But next, we're going to look at something that is far, far, far away. And it's a galaxy. It's called M82. And it's a galaxy that is in Ursa Major. And it's also called the Cigar Galaxy. So I'm going to move over to that next while Jim tells you about it.
All right, so yeah, this one's a really cool galaxy. So when Bernie gets to it, what we're going to be looking at is we're going to be looking at an edge view of a galaxy that's 12 million light years away. So the light we're going to see in the telescope is 12 million years old. That's how long it took that light when it left the galaxy, traveling at the speed of light to get to your eyeballs. M82 in recent times, and that recent is in geological times, of about 100 million years ago, so that's fairly recent, went through an encounter with its nearby galaxy M81, which we're going to look at next. And they're only separated, I believe, by only about 150,000 light years. So they're fairly close. So if you were on a planet around the star in either one of those galaxies, the other galaxy would be very large in the night sky and would be an awesome sight. The supermassive black hole, and I'll explain what a black hole is in just a minute, at the center of M82 is approximately 30 million times the mass of our sun. So when we talk about supermassive black holes, we generally say they have so many solar masses. So this is 30 million solar masses. So our supermassive black hole at the center of our Milky Way galaxy is only about 4 million supermasses. So this one is considerably larger. This galaxy is in a magnitude of 8, so it's not visible to the naked eye, and it's in the constellation Ursa Major, which is the constellation that holds the Big Dipper visible to the north. So what is a black hole? A black hole is an object that is pretty small in size as compared to the galaxy that it's probably in. The black hole in the center of our galaxy is probably about the size from the sun out to maybe Venus. So it's fairly small, but it's still got 4 million masses of the sun. So why it's called a black hole is because its gravity is so strong that light can't even escape, which is why it shows up black. So the only way astronomers are able to take pictures of a black hole is by taking a picture of the material going around the black hole. So if you remember last summer, I think it was, using the Event Horizon telescope, which is a bunch of telescopes linked together, encompassing the entire Earth, they took a picture of M87, and the supermassive black hole in the center. And so you saw a black center and you saw the material going around it. That supermassive black hole was, I believe it was 100 billion solar masses. I think does that sound right, Bernie? 100 billion solar masses for the center of M87? I was big. I think it was that big. I'm not sure positive of that, but it was much larger.
You caught me off guard,
Yeah.
Jim. I'd have to look it up.
But Google M87 and you can kind of see how big it is. So, and most galaxies do have a black hole in the center. It's part of what holds the galaxy together. It's not all that holds it together. There's some other stuff that does it as well. But yeah, I think that's interesting. So what you're looking at there, Bernie, why don't you explain a little bit what they're seeing?
Okay, M82, the cigar galaxy, and you can see why it's called a cigar. It looks like an elongated object. It's an edge-on galaxy, so we're looking like at a plate from the edge on, and you'll notice right away that there are kind of darkish lumps in it as well as bright areas. And those dark areas, in particular, the one that goes right down the center, and also some over on the right-hand side, those are huge clouds of dust that are obscuring some of the light from the galaxy itself. We also have a fly that wants to bug us through the galaxy, so we'll get the fly out of there if we can. There we go. Flies usually aren't part of galaxies, don't worry. And then you'll also notice there's some kind of reddish zones in there that look a little brighter. Those are huge star-forming regions within the galaxy itself. This is M82 is a prolific star-forming galaxy. There's a tremendous amount of new stars being born in M82.
All right, there was a couple of questions that somebody asked if we could look at the whirlpool. The whirlpool is not, I think, quite. It's kind of low, isn't it, right now to the north view?
We're not going to look at the whirlpool, but we're going to look at the pinwheel later on, which is very, very similar to the whirlpool, and I think you'll like it.
And Carlos asks what setup you're using. When we first got started, and Carlos, maybe you came in a little bit late, Bernie kind of explained what system he's using, so if you get a chance later, maybe tomorrow or something, just kind of replay the intro and he'll talk. He's using a Malin cam on a C8. You don't have the Hyperstar on, do you?
No.
No, he does have a Hyperstar, but he doesn't have it on tonight. Okay.
Now the next object we're going to look at is another galaxy called M81. Now actually it's right next to M82, so I'll just slew a little bit to the side, and we'll pick up M82, which is its companion galaxy, and these two galaxies go through the universe together as a pair.
And this will actually be M81.
I'm
You
sorry.
said 82, that's right.
I'm sorry.
We're on 82 now, so we're going to 81.
Getting my numbers mixed up.
Well, and usually we do 1 first and 2, but M82 is kind of concentrated, looking at an edge-on galaxy. And just in case, I think I explain it later, but a galaxy, if you think about it, galaxies are basically like a city of stars. And so most of them, or a lot of them, are spiral galaxies. There's elliptical galaxies. There's irregular galaxies, all kinds of different kinds of galaxies. Most of them are fairly flat, and some of them are, a lot of them are pretty big. So, like in our Milky Way galaxy is about 100,000 light years across from one edge to the other, but it's only about 1,000 light years thick. So 100,000 across, 1,000 thick. Our solar system is about halfway out from the center of the Milky Way galaxy. So we're about 26,000 light years from the center. We're out in the suburbs, which is good because it's a lot quieter out here. It's, planets probably have a tough time forming in the central bulge of the galaxy. And what you're looking at when Bernie gets it on the system here, what you see in that really bright part is the core or the central bulge. And probably about 1/3 of the stars are in that part of it. So M81 it's called Bode's galaxy. As Bernie mentioned, it's right next door to 82. It was discovered by Johann Bode at the same time as M82 in 1774. It has a visual magnitude of about 7, so it's not visible to the naked eye, but may be visible in binoculars or small telescopes. So when you're looking for M81 or M82, we're going to be looking towards the north. So you're going to find the Big Dipper. What you want to do is you want to go about 10 degrees, so 1/5 length, below and slightly to the left of the last star at the end of the Big Dipper bucket. So you'll have kind of some the bucket and the outside stars, we call those the pointer stars, and I'll talk about that in just a minute. About 10 degrees below and slightly to the left, you should have M81, M82. In binoculars, they'll just kind of look like maybe a little fuzziness, something like that. Let's see. M81's supermassive black hole is about twice that of 82. It's about 70 million solar masses. So if you look at the Big Dipper, the two end stars, the bucket stars, so looking to the north, you'll see the handle, and then you'll see the bucket. The two outside stars, we call those the pointer stars. And they always point to the North Star. So if you follow those in a line, looking down, you will come to Polaris. Or in this case, I think you're actually looking maybe a little bit to the left. And and Polaris is the star that is at the end of the handle of the Little Dipper. And if you've got really good skies, you can might be able to see all of the Little Dipper stars. Each one of the stars in the Little Dipper is a different magnitude. The dimmest one is one of the inside stars of the bucket of the Little Dipper. That's probably the toughest. Most people can see the Polaris, which is the North Star, and the two end of the bucket stars. So the Polaris is off our north polar area of the Earth. So everything rotates around that. So if you can find Polaris, then you're looking north, and from there you should be able to find all your other cardinal directions. So if you need to find a cardinal direction out in the middle of the desert or someplace, the North Star will help. I think Bernie's hunting flies right now. All right, so if you look at the screen, you can actually see some really a fair amount of the arms of the galaxy.
Right. Obviously, you can see the center core of the galaxy. And remember, galaxies are billions and billions of stars. So a good portion of the galaxy's stars are in the central core, but then from the central core, you can see spiraling arms that spiral out. And I hope you can see those on the screen there. There's another one that comes out this way, and then there's another big one that comes around that way, and way up here in the image. Those are the spiraling arms of the galaxy, and those are stars as well. Those stars are just like the Milky Way, very similar in appearance. If you looked at the Milky Way from this kind of distance, it would look similar to this. And one thing we like to point out is our sun is not in the center of our galaxy. Our sun is about 2/3 of the way out. So we, on Earth, going around our star, is way out in one of those arms of the Milky Way. Just like you're seeing the arms of M81 here.
All right, while Bernie's getting ready to go to the next one, there were a couple of questions, but Bernie, you can go ahead and slew. I think the next one we're going to do is a comet.
Right. We thought we'd do something a little different here. Instead of the usual stellar objects and galaxies and stuff, we'd show you a comet as well. There's a couple of fairly bright comets in the sky right now. Both of them are require, as a minimum, a good pair of binoculars or a telescope. But we're going to take a look at one of them. It's called Pan-STARRS, Comet Pan-STARRS. And I'm going to slew over to that
All right.
while Jim's talking about it.
All right, so let's see. Somebody asked how late we're going tonight. We're planning on going until 9:30. Our next event, we're going to do these virtual star parties, probably a couple more before we get stuck in our monsoon here in Tucson, and then we'll be taking a break over the summer. But our next one's going to be May 12th, Tuesday, May 12th. It'll be a little bit later because the sun's setting a little bit later. It'll go from 8:30 to 10. And there is an event on our Facebook page as well as on our website. Yeah, this is the first time we've done this virtually. We do a lot of in-person star parties here in Tucson. So unfortunately, we've had to cancel all those. Our next in-person one right now is going to be scheduled at Agua Caliente Park on the northeast side of town in September. And that should be listed on our Facebook page as well. Okay, so this one's a little bit different. We're going to a Comet Pan-STARRS. It's also called C2017T2. C means it's just a periodic comet. T2 means that it was discovered. T2, the T is the month, so it's the second half of October in 2017. That's how it kind of works. And it was discovered by the Pan-STARRS Sky Survey Telescope. I think that's in Hawaii. So at this time, at the time that it was discovered, it was nearly as distant as Saturn. And it was a dim plus 20 magnitude. This comet is on its first trip into the inner solar system from what's called the Oort cloud, which is a sphere of icy comets and leftover debris from the formation of the solar system, well beyond Pluto, and Pluto's part of the Kuiper belt. So the Kuiper belt kind of starts with Pluto and goes out about 50 times the distance of Earth to the Sun. So We are 93 million miles from the sun. That's called 1 astronomical unit, or 1 AU. The Kuiper belt goes out to about 50 AU, and then from 50 AU, probably out to about a light year and a half, maybe 2 light years, about halfway over to the Alpha Centauri system, is the Oort cloud. And this is a big sphere of icy comets. And so sometimes things get jostled out there a little bit, and they get kicked into the inner solar system. The sun's gravity is pretty weak out there. So it takes a little bit of a nudge by something, a passing star, maybe going through some dust, and it can kick them in. So this comet is coming in from the Oort cloud. Let's see, it's on a 500-year orbit around the sun. You might be able to spot it with binoculars, but it's probably going to be pretty dim for that and pretty diffused. Certainly, even visually with the telescope, it's probably getting pretty close to its brightest right now. You might be able to see it visually. Certainly, it's showing up in Bernie's camera. To find it, what you want to do right now, and this is going to change as tonight moves on because this comet's moving at a pretty good clip. If you find Polaris, which is the North Star, so again, you go to the Big Dipper, find the 2 pointer stars, move over to Polaris, then look toward the west and find the bright star Capella, which we talked about earlier. That's the circle, the constellations, that's the circle of stars in the west. The bright one is Capella. So we used a ride to find the Crab Nebula earlier. So once you find Capella, then you go back to Polaris and imagine a line between Polaris and Capella, and look about 1/3 of the way along that line from Polaris, and you're looking for a little fuzzy object. It'll look like maybe an out-of-focus star. You won't be able to see much of a tail with it. We're barely picking up a little bit of a tail here, and Bernie will point that out in a minute. Again, it's not naked eye visible, and it's probably going to be a tough find unless you've got a pretty good-sized telescope. And if you look right, so there's the core of the comet. And then you can kind of see, I think that's the tail coming down, but Bernie, I'll let you talk a little bit about it.
Right, it actually shows better in the Facebook image than what we're seeing here, surprisingly, but you can see the inner core, and then also what's called the coma, which is the ionized cloud that surrounds the inner core, and then trailing behind, very faintly, but trailing behind is the tail of the comet. This particular comet has gone through some variations in tail brightness. Right now it's a little dimmer, but about a week ago it was a little brighter. So it kind of depends on when you look at it. I'm not sure if you can tell on your image on Facebook, but the coma has a slight greenish tinge. And that greenish tinge is from a ionization of a cyanide derivative that's inherent in the ices of the comet itself.
One of the questions we have here, let's see, from Ali, how long is the biggest comet? It really depends. Halley's Comet was considered one of the great comets. It comes around every 74 years, I think.
Yeah, it was very disappointing back in '86. I'm showing my age. I did see it in '86. I was rather disappointed. But Comet Kohoutek in 1973 was spectacular. I saw that in binoculars, and I'll never forget the view of that. It filled the entire screen of the binoculars. We're live. I think some of those questions have been answered. I appreciate all my TAAA buddies here answering some of these questions. That's helping a lot. Sometimes I kind of have to search to try to find them, and hopefully we're getting them all answered, but we'll look through and
and try to do that as much as possible. So we only have roughly about a half hour, so we're only a little over halfway through, so we'll maybe try to pick it up a little bit more and get to some more. So let's go to the next one, Bernie.
Do you want to do Mizar?
Yeah, let's do Mizar.
Okay. We're going to go to a double star called Mizar and Alcor, and they are in the Big Dipper.
All right, so while Bernie's swinging over, we're still in the north, and this is a multiple star system. So if you're looking to the north, you're going to find the Big Dipper, and look at the second star from the end of the handle, right at the curve. That star is Mizar, that's the brighter one. And then just below it, and slightly dimmer, is the star called Alcor. This system is about 80 to 85 light years away and was used back in ancient times as an eye test. So if you could see the two stars, your eyes were good enough to be a hunter. Otherwise, you stayed home with some other job. Well, truth be known, it's really not that hard to see that second star. So they had plenty of people getting drafted into the hunting cadre. There is a 2 magnitude difference between the brighter Mizar at +2 magnitude and Alcor, which is +4. So again, a higher number, the dimmer it is. So once the telescope gets there, I'll talk a little bit about the multiplicity of the system. This one, so you can see it visually with just your naked eye, but what you're going to see is you're going to see a brighter Mizar and then a dimmer Alcor. Now Bernie's going to pull back the integration a little bit, and that bright spot right in the middle will slowly become 2 stars.
Maybe we should point out, this is Mizar and this is Alcor.
So now while he's doing that, let me talk about the 2 stars. So through the telescope, Mizar is going to show as 2 stars and Alcor as 1. The 2 Mizar, and Mizar actually has 2 additional stars that we can't see visually, but have been found using something called spectroscopy. So Mizar is actually a quartet of stars. The 2 we can see, and each one of those stars has another pair. The 2 pairs of Mizar stars, Mizar A and B, are at least about 500 astronomical units apart. So that's 500 times the distance of the Earth to the Sun at 93 million miles. So 500 times 93 million miles is approximately how far apart these two pairs are. So again, if you were on a planet around one of these 4 stars, the other 3 stars would be pretty close and pretty bright. The one that's really close certainly would be, and then the other 2 would still be fairly bright as well. Alcor is the single star below or to the left, in this case, of Mizar. If you're looking visually, it's below. And Alcor is actually a double itself with a very close dwarf companion. So that one is tougher, even tougher to see, and takes about 90 years to orbit the main Alcor star. You can't even see the second star with the telescope. Astronomers do believe that even though they're fairly far apart, that the Mizar and Alcor are gravitationally bound to each other. So assuming this is true, then this system is a sextuple or 6-star system. And you can see 3 of those 6 visually. All right, Bernie, ready?
Should we skip the next one and go on to M3?
Sure.
Just to
Speed things
make
up
up
a
a
little
little
bit.
time.
If we get a chance, we'll come back to that. But yeah.
Yeah. Okay, so the next object we're going to is a different kind of object here inside our Milky Way galaxy. It's called a globular cluster, and it differs from open clusters. It's called M3, and it's in the constellation of Canis Venatici.
All right, and I think somebody did ask earlier how long we were going, and I said we're going till 9:30 our time, so roughly another half hour. But if you do have to leave, this should be recorded on our Facebook page, so just come back, look under videos, and then you can play it at your leisure, and we hope that you do that. All right, so yeah, this is a globular cluster. So now we're looking at very old stars. As stars age, they tend to group together in small clusters, and we call them globulars or globs. Most stars in globs are almost as old as the universe, and some of the first ones formed in the Milky Way. So the universe is estimated to be about 13.8 billion years old. Globs tend to cluster toward the center of our Milky Way galaxy and usually above or below the plane of the galaxy. So if you remember, I said the Milky Way is about 100,000 light years across and about 1,000 light years thick. If we were to look back in kind of towards the center and then above or below the core of the galaxy, that's where the globs are going to kind of hang out. Most of them. M3 contains probably about 500,000 stars in a tight ball, only about 200 light years across. So that's a lot of stars in a small area. And if you were on a planet around a star in that cluster, you would have a lot of very bright stars. The cluster's age, in this case, is about 8 billion years old, so it's kind of young, one of the younger globs. If you look toward the northeast and again locate the end of the Big Dipper handle, that star is called Alkaid. We have a saying that from the Big Dipper handle, you arc to Arcturus. So if you follow the arc of the handle to the next brighter star to the east, that star is called Arcturus. Now you want to use an imaginary line between Arcturus and Alkaid, so a straight line. Go about 1/3 of the way from Arcturus, so not the end of the handle, but go to Arcturus and go 1/3 of the way back toward Alkaid, and then about 4 degrees or about half a fist above that line. And you're going to look for a fuzzy object. That is M3, that's the glob. It's at a magnitude plus 6.2, so it's just barely outside of visual, so you should be able to pick it up, certainly with binoculars, maybe visually if you've got some dark skies. It's about 33,000 light years away. So I said earlier the solar system was about 26,000 light years from the center of the Milky Way, or about halfway out to the edge. So M3 is probably just a little bit on the other side of the center because it's 33,000 light years away. It is one of the 3 brightest globs in the night sky. And like I said, under some dark skies, you can actually see it visually. One of the things through telescopes or even binoculars or even visually, when you're looking for faint objects, you want to try to use your averted or peripheral vision. So what this means is that the central part of your eye is not as light sensitive and is poor vision during night viewing. So when you look through a telescope or even just with your eyes, your peripheral vision will make it a lot easier to see dim objects. So when you get to where you want to look, then just kind of look off to one side or the other and try to look out of the corner of your eye. Don't look right at it, but just kind of look out of the corner of your eye and out of your periphery. Your side of your eye, you're going to see a little bit of fuzziness. If you try to look right at it, it might disappear. So it's real important to try to use averted vision. And there it is on the screen.
Globulars are of special interest to me. I've enjoyed photographing them. And I remember reading a Ray Bradbury short story about a civilization that lived on a planet orbiting one of the stars in a globular cluster. They didn't know it. The stars were out all the time, so it was always daylight, except for once every several hundred years when all the stars would align on the opposite side of the sky and they'd have darkness for the first time. And they all went insane because they didn't know what darkness meant. Just interesting story if you ever read Ray Bradbury.
Yeah, real quick, we had a question from Ali that was asking why is the Milky Way galaxy called the Milky Way? Now, that's a big question. And I think
I'm going to move to the next topic
Okay,
while you're
yep.
talking about that, Jim.
So back in the day, and now even from a dark site, if you look up in the night sky, especially in the summer, you see the streak going across the night sky. It kind of starts in Cassiopeia and goes south towards Sagittarius. What you're actually looking at is the next arm of our Milky Way galaxy back in towards the center. and that streak looked like a river, and it looked like a river of milk, I guess, back in the day. And so that's kind of why they called it the Milky Way. And we can still see that in the night sky from a dark sky. All right, so now we're doing the Pinwheel Galaxy, which is M99.
Right, someone asked earlier if we could do M51, and we're going to do the pinwheel instead. I think you'll, if you know M51, I think you'll like what the pinwheel is. It's also called M99, by the way.
All right, so this is a face-on view of the spiral galaxy. So we're looking kind of down from the top, so to speak. And so you're going to see the spiral arms splayed out in all their glory. It's about 50 million light years away. So think about it. The light we're going to see in the telescope, this is live, through the camera, that light left that galaxy only 10 to 15 million years after the dinosaurs went extinct. So that light has been traveling towards our eyeballs for 50 million years. This galaxy is in the constellation Coma Berenices, or Bernice's hair. It's one of the fainter Messier objects at a magnitude of about +10. So it's way outside of visual. You won't be able to see it in binoculars. To see it visually, you'll need a pretty good sized telescope. Bernie will tweak his system to kind of pull out the faint spiral arms. The arms kind of curve counterclockwise around the galaxy. This galaxy is about the same size as the Milky Way at about 100,000 light years across. Even though the galaxy appears in Coma Berenices, it is part of the Virgo cluster of galaxies. So there were several supernovas that have been detected in this galaxy. So it's kind of right on the outer edge of Coma Berenices, and it's in Virgo. So we talked. I was going to talk a little bit about galaxies here, but I think we pretty well covered everything in here. This is a spiral galaxy, so this is going to be a really gorgeous one once Bernie gets the system tweaked. So Jennifer is asking a question while Bernie's tweaking that a little bit. Why do we look at stars to guide our ships? Great question. Back before we had GPS, and go figure, back in the day, especially mariners, they had to use stars to navigate, and they used what's called a sextant. And if you Google that, you'll kind of see what it's used. It's used to figure out your latitude and longitude on where you're at on Earth. So, you know, if you can look at like Polaris, we are here in Tucson, we're at 32 degrees latitude. So Polaris is going to be 32 degrees above the true horizon. I think I have that right. And so the further north you are, the higher Polaris is going to be. So if you're at 60 degrees in latitude, then Polaris will be even higher. It'll be up at 60 degrees. So using a sextant, you can measure how high the stars are. Longitude gets a little bit trickier, and I don't even want to try to explain that because I'd screw it up. But if you it's a really good research project to see if you can kind of get an idea of how to do that. But yeah, it was. I'm amazed that they were able to do as much as they did. So that's a phenomenal question. Now you can really see the spiral arms nice and clearly on here, arcing on. So there's the core again, and here's the spiral arms coming out around that galaxy. It looks like it's got 3 main sets, probably.
Yes.
And it's even faint in Bernie's camera, so this would be really tough to do visually.
Yeah, this particular object is only 5 arc minutes in size, so it's quite small. You'd need a very good telescope to pull this out and see the arms. Most telescopes would only show that center dot in the middle, and you'd think you were just looking at another star. So it would be difficult to spot visually. You almost need a camera and an ability to integrate the image to pull out the spiral arms on this one.
Bernie, somebody asked what was the name of the book that you mentioned earlier about orbiting stars?
It was one of Ray Bradbury's short stories. I don't remember specifically what the name of the story was. I'd have to look it up.
Peter said he thinks it's Nightfall. Does that sound right?
That's very possible. I couldn't guarantee it. It was a long time ago when I read it.
All right, so we got one more to go in about 15 minutes. We might have time to go back and check out the Leo triplet. But
All right, the next one we're going to do, it's another galaxy, and it's one of our favorite galaxies to show, especially this time of year when it's visible in the night sky. And it's called the Sombrero Galaxy, or M104.
all right, yeah. So this will probably be our last one. The Sombrero Galaxy is a really, really cool galaxy to look at, both visually and especially with the camera. It's going to be an edge. It's probably one of the best edge-on views of a galaxy. The sombrero gets its name because it looks like a sombrero hat. So when we look at it, it's going to have a dark dust lane passing through the center of the view, which kind of looks like the brim of a sombrero. You'll be able to see the bright galaxy core above and below, so that'll be kind of the core of the hat. And then the dark dust lane is the brim of the hat. It's in the eastern sky right now. So again, you arc from the Big Dipper handle to Arcturus. So go from Alcade, arc over to Arcturus. And then you want to speed to the next brightest star in a straight line toward the southeast to a star called Spica or Spica. You can pronounce it either way. You speed to Spica or spike to Spica from Arcturus. Then you want to curve to a constellation called Corvus the Crow. I don't see anything close to a crow here, but what it is, it's a polygon or an object that kind of looks like a square but has uneven sides. So you're looking to the east, you're looking at Corvus. The star in the upper left corner is Algorab. So that's in the upper left corner of Corvus, of the 4 stars that you can see. From there you want to go about 5 degrees, so half a fist, above and to the left at about a 45-degree angle from the line that goes between Spica and Algorab. So along that line, then you go from Algorab, you go back about 5 degrees, and then go up about 45-degree angle above that. And you're going to look for a fuzzy spot, and that'll be the galaxy. This one is magnitude +8, so probably won't see it naked eye, but you might be able to see it with binoculars. The sombrero is about 30 million light years away. So the light we're looking at is 30 million years old. And again, we're looking at the edge of it, so that's why it looks rather skinny. Like I said, galaxies are only generally about 1,000 light years thick. You can see the edge of the disk with the dark dust lane going through, and the glow that you're seeing is the core, and the.
It'll clear out in a minute.
So yeah, it's starting to look better and better as he comes up with it. The nice thing with Bernie's system is with live video, it stacks it almost real time. It does it very quickly. He's using the software that came with the Malincam camera. So these, if you Google Malincam, you should come to the website. I think it's a Canadian company, isn't it, Bernie?
Yes, they're out of Toronto.
And they have the great cameras. They're great for doing outreach. He'll set up his laptop when we do live star parties and very quickly be able to show a lot fainter objects than we can visually. Well, that's gorgeous.
Yeah, the nice thing about the sombrero is you see the very obvious dust lane along the edge of the galaxy, and then although the central core is more predominant on one side, you can slightly make it out on the opposite side as well. And that indicates that the view that we have of this galaxy is not exactly edge on, it's tilted just a few degrees from exactly edge on. So we're seeing one side of it more than the other.
Well, we still have a little over 10 minutes. You want to try to sneak in the Leo triplet real quick?
We could give it a try.
All right, so while Bernie's doing that, let me talk about it. So we are going to try one more. This is, it's called the Leo triplet, so it's in the constellation Leo, so you have to go back to the west a little bit, probably almost straight up. We'll see if we can get it in there. This is Messier, or M65 and 66. In the telescope, he'll certainly be able to get two galaxies out of there. May or may not be able to get the third one, probably not.
Very difficult to get all three of them in the optical system that I'm currently operating here. If we use another type of lens called a hyperstar lens, then you can get all three, but it didn't serve us well for looking at these smaller objects that we wanted to do tonight.
Yeah, if I use a wide field view in like my 8 or 11 inch, I can usually get, at the Grand Canyon Star Party, I can usually get all three of them in there, but they pretty well go edge to edge. So the third galaxy is called NGC 3628, so it's a little fainter, but we'll certainly be able to get 65 and 66. These guys are much further away than 81 and 82. They're about 35 million light years away. So again, the light left the galaxies 35 million years ago. It kind of alluded to this. I don't remember if I said it earlier, but basically when you do astronomy, you're doing time traveling. You're looking at objects as they were back in however far away they were. So it's kind of cool, especially when you look at some of these further away galaxies and things like that. Let's see, they're both face-on views of the galaxy, with M65 a little more of an angle. So M66 is going to be a little flatter. If you can hold your binoculars steady enough or mount them on a tripod, you might be able to see these with binoculars if you have a dark sky. So what we're going to do is we're going to find Leo the Lion again, which we found that earlier. So this, if you go back to the kind of the east, let's see, yeah, so toward the east, we're going to be looking for Regulus. So if you kind of look straight up, you're going to see a backwards question mark, and the bright star is the main of Leo, and that's called Regulus. So once you find Regulus, look about 25 degrees, or about 2.5 clenched fists below and to the left, toward the east a little bit, for the next brightest star in the tail of the line called the nebula. So now we're going to use an imaginary line between the nebula and Regulus, and so along that line you want to look about 7 degrees, or about 2/3 of your fist, from the nebula with your binoculars or a telescope, and look for some fuzzy objects, and those will be the galaxies. So they're right along that line, about 7 degrees from the nebula. The visual magnitude is about 9.5, so you might not be able to pick them out with regular 10 by 50s. You're probably going to need to have a telescope, but give it a try. M65 is about 80,000 light years across, and 66 about 75,000 light years. So they're both slightly smaller than our Milky Way. And there they are. Go ahead, Bernie, if you want to talk about them a little bit.
Right, I'm waiting for them to clear up a little bit here while it builds up a better image. That's a little better. And I'm going to zoom in just a little more so we can see them a little more clearly. Okay, so we've got two galaxies here. They are part of the same group of galaxies, and they are probably gravitationally bound together. And now what that means is that they will travel through the universe as a pair, together, side by side. This one in the upper left is called M66, and the one in the lower right is M65. The M66 is more of a face-on, so you can see that it's facing directly towards us, whereas M65 is more of a tilt. I guesstimate maybe 45 degrees from face on. And if we zoom in to the individual ones, we do that, you can see the spiral arms of M66, that it kind of appears to be a barred spiral. What we mean by a barred spiral is, rather than spiraling out right from the center out to the outer edges, there'll be what appears to be a bar, and the arms will spiral off either the ends or parts of the bar itself. And you'll notice again here with this, there's two major arms, one coming up this way, another one coming down, and there are clumps of brightness within the individual arms. Those are star-forming regions. So there's a lot of new stars being developed within that galaxy. And then if we look down on M65, this one appears to be more, for lack of a better word, quiet. It doesn't have quite as much star forming going on. You can see a few lumps, one there, a couple right in there, that show a little bit of star forming, but mostly just the beautiful spiral arms, and it looks like a dust lane right through there as well, cutting between the individual arms of that galaxy. As Jim was mentioning, there's a third one. It's just outside the field of view of these two. It would be difficult to go and try to find. It's fainter, so I think we'll pass on doing that tonight. But you've got the gist of the triplet by looking at the main two galaxies.
All right, cool.
So do we have any additional questions that maybe we'd want to answer in our last few minutes here?
So there's a couple on here. Is Bernie using an equatorial or alt-azimuth mount, is what Ryan asks.
Okay, this is, as I mentioned earlier, this is a Celestron AVX mount, and it's an equatorial mount. Very good question, thank you.
And yeah, Peter brought up, and this is relatively new news that he heard, and it is true that the Grand Canyon Star Party has been officially canceled as far as being a live event. But we are going to take a look at trying to do a lot of it virtually. I think the plan is to maybe do some of the presentations or all of the presentations online. Certainly we can do an event like this that covers some of the night skies and things like that. So yeah, hopefully, it's sad that it had to be canceled, but
we might end up doing some kind of virtual star party instead.
Yep. We got a question from the 355th Force Support Squadron. What is the most interesting object you've seen through your telescope? Well, I'll give you my perspective and then I'll let Bernie talk, but I always enjoy looking at Saturn and Jupiter. The planets are just amazing visually in telescopes, so those are fun. Probably the most interesting thing that I've looked at is when I can look at multiple galaxies in one field of view, like the triplet at the Grand Canyon Star Party. I just never get tired of looking at galaxies.
Yeah, I'd have to say the same thing. Galaxies have always been my favorite, and any one particular galaxy, obviously Andromeda will blow your socks off. to the first time you see Andromeda, especially imaging it with a camera. Unfortunately, we can't show that to you. We'd love to, but unfortunately, Andromeda is in the constellation Andromeda, which is not visible at this time of year.
All right, another question from Jacqueline. Is it possible, she just moved, is it possible for black holes to swallow large objects such as the sun? Absolutely. Now, the good thing is that we live 26,000 light years away from our big black hole in the center of our galaxy. So if we were around a star, or on a planet around a star, which would be tough, in the center of the galaxy, it would be very much a lot of turmoil in there. But stars, you have to get pretty close to a black hole to actually get absorbed into it. Black holes love gas, but they will tear apart stars. But again, we don't have to worry about that out here because we live out in the suburbs, and that's a really good thing.
As far as we know, there's none close by that we got to worry about.
Yep. Right now, just so you know, if you were with us earlier, Venus is visible in the west. In the really late, probably about midnight or after midnight right now is when Saturn, Jupiter, and Mars are coming up. So they're kind of a morning object right now. But
2 a.m.
yeah, Jupiter and Saturn will be back in the evening, late May to early June. So we'll certainly, hopefully, be able to show some of those if we do a virtual Grand Canyon Star Party or any of our other kinds of events. All right, so let me just kind of wrap things up. I think this was a huge amount of fun for us.
Did you have another question, Susan?
No, I think that was it.
Well, someone is asking, are there major sky events coming up that we should be sure to catch?
Let's see. No, there's ongoing meteor showers, but
well, there's the Lyrid
Lyrid's
meteor
going on right
shower,
now.
but that's actually tonight.
yeah, that'll be
Yeah.
visible in the wee hours of the morning. Will be the best time to see that.
After midnight.
Yeah, if you get up early, you want to look for a bright star called Vega. Get out your app, your astronomy app, look for Vega, and that's the constellation Lyra. And they're going to kind of emanate from there. But it's a pretty weak meteor shower. It's only usually about 10 to 15 an hour. It's tough for me once I'm in bed for me to get back up for something like that. But if you want to give it a shot, go out and look for a half hour or so and see if you can see any. But other than that, I don't know that there's much else coming up.
There was a comet, it was called Atlas, that looked like it was going to be spectacular later in May. Unfortunately, in the last week to 10 days, it has broken apart as it's approaching the sun and fading out, and it doesn't appear to be anything anywhere near what they had hoped it would be, which is unfortunate because it's about time we had a nice bright comet, but I guess we're going to have to wait a little longer.
John mentioned or asked how many school presentations we do each year and what helps you do. You go to these. Helps you go to do these.
Oh, God,
we
count them all.
Yeah, we do over 200 star parties a year. Again, about half of those are for probably for schools or youth groups, and then we do some public ones, and we do some for the resorts. And we have TAAA has a core of probably about 60 volunteers. We're an all volunteer organization. We have about 400 members, but about 60 volunteers that are actively involved with doing the Star Party program. Some volunteers may only do 1 or 2 a year. I've got several that will do half of them or more a month. Some months, usually February, March, and April are our busiest months in normal years. We'll have as much as maybe 20, 25 events, sometimes up to 30 events in a month. So it's really busy. And, those are generally compressed into about a 3-week time period because we stay away from the full moon week as much as possible. So yeah, they're a lot of fun. It's a great time to be able to do some outreach. We also, and Terry mentioned on there, and if you want to check it out, we participate in the Night Sky Network. There's, I think, a link there that'll get you there, and you should be able to see some public events on the Night Sky Network as well. This is the NASA Night Sky Network. I think there's another one that is up in Canada or something that the Mellencamp folks are involved with. This is the
NSN.ca, I believe.
Yeah. All right, we probably need to wrap this up. So again, our plan is to try to keep doing these even once we get back to doing live in-person star parties here in Southern Arizona. So, we'll try to do them monthly or quarterly, especially once we get past monsoon. We'll try to record these to our Facebook page so that you can go back and so this one you should be able to go back and review again. We will create an event on Facebook like we do for other star parties for the virtual one. So just a reminder, we're planning on doing the virtual one, the next one, May 12th. If we get weathered out, if we have weather issues, I usually post something on the event, so it's a good idea to follow that event so you get any kind of updates if you can. Let's see, we'll also put them on our website calendar, on our TAAA website calendar, and on the NASA's Night Sky Network calendar. Let us know if you have any comments or inputs, whether they're good or bad, what we can do better for future. Spread the word on these. I think this is a great opportunity, especially for anyone living in light polluted skies, to enjoy a star party. We'll feel free to share the event, with family and friends. Like or follow our page if you want to get updates on stuff we're doing. We'll also post blogs routinely on our website. So if you go to TucsonAstronomy.org, look on the left, you'll see blogs there of what's going on in the night sky. This is also International Dark Sky Week. So there's lots of activities going on online. I put some of the links to some of those on our Facebook page, so look for a recent post that's got them all on there. Or you can also go to the Dark Sky, International Dark Sky Association. They have a list of events going on. It's the Dark Sky Week page is idsw.darksky.org. And a lot of them, they're doing some reading, kids' books and things like that. So a lot of them focused on the children. So again, on behalf of all of the Tucson Amateur Astronomy Association members, thanks for watching. A great shout out for the Davis-Monthan team. We are really good for that. So I hope you guys enjoyed it. Bernie, you got anything closing?
Well, in parting, someone asked for M51, the Whirlpool Galaxy. Here you go. This is M51 in Ursa Major. And thank you very much for joining us this evening. On behalf of Jim Knoll and Susan Knoll and myself, Bernie Stinger, thank you for coming.
All right, thanks. Till next time.